Good morning, Dr. Zikri. Today, our team will do a presentation about our assignment titled Investigation the Effect of Electromagnetic Interference Due to Radiation and Emission. There's Gabriel in our team, and Brendan, and also Patricia, and me, Tan. Okay, moving on. This is the objective for our assignment. The first objective is investigate the behavior of radiated emission produced by the spark voltage of ignition coil. And the second objective is categorize the highest peak of radiated emission by considering the common parameter and impulse signal. Okay, next. This is how the arrangement of the measuring spark voltage using voltage divider. And B is the image of spark voltage obtained from the oscilloscope. From figure A, you can see that the ignition coil is connected to the resistor, which is 280 mega ohm. Okay, then it is connected to the 14 kilo ohm, and then to the oscilloscope using coaxial cable. And the grounding is connected to the grounding, which is the red wire, and the green wire, which is connected to the body. Okay, next. This is the experiment set up for the radiated emission. This is how it's supposed to connect the system for the radiated emission, so that it can get the signal. Okay, next, Brendan.
Okay, this is the radiated emission result that is taken from the data that Zikri has sent to us. We use a MATLAB to getting this data. This data has four. They have a different distance that is 1.5 meter, 1 meter, 0.4 meter, and 0.2 meter. From the data, we can see the shorter the distance, the higher the amplitude getting. For the highest amplitude is 0.2 meter, is 15.08 volt. And the others will be the rising time, the volt division time will be higher than the 1.5 meter. Okay, then time division and the overall path duration, zero processing time, highest path, warehouse full width, 50% of fixed are all the same. Okay, next. Okay, this is data for 1.5 meter. Okay. This is for 1 meter. And this is for 0.4 meter data. And lastly is 0.2 data of the graph that is being plotted in MATLAB.
Okay, I will take over next for the discussion. So it's for the discussion. This assignment has presented a thorough exploration of radiated emission within the realm of electromagnetic compatibility, which is EMC. It underscores the significance of understanding and controlling these emissions, which arise from the unintentional release of electromagnetic energy in electronic devices. The distinction between radiated emissions from the current flowing in a loop on a straight wire is elucidated, emphasizing the interconnected relationship between changing magnetic and electric fields that give rise to radio waves. The shift from closed field to far fields is detailed, showing its frequency-dependent nature and its connection to the wavelength corresponding to the frequency of the source. The discussion extends to the concept of wave impedance, where the ratio of electrics to magnetic fields reach equilibrium in the far field, consistently measuring at 377 ohms. This also delves into the practical aspect of measuring radiated emissions using antennas, various antenna designs, and necessity of testing multiple directions around the device under test, which is duty, for EMC compliance. Further, it touched upon susceptibility testing using high-powered RF or EM energy that challenge force by transient pulses emphasizing the importance of environmental consideration in testing scenarios involving large antennas. So overall, these assignments provide a comprehensive overview covering the theoretical foundations of measuring techniques and practical consideration related to the related emission of the context of electromagnetic compatibility. Alright, next I will give to Patricia.
As for the conclusion, the behavior of the radiated emissions from an ignition coil spark voltage is investigated, and the results showed that these emissions may cause electromagnetic interference problems for adjacent electronic devices. The peak voltage of the ignition coil spark discharge usually indicates the maximum peak of radiated emissions characteristic and reducing the impact of radiated emission on electronic system in cars and other machines may be made easier with an understanding of the common properties of impulse signals. The effect of radiated emissions on delicate electronic components can be reduced with the use of techniques including shielding, filtering, and appropriate grounding. That's all from us. Thank you.
Okay, that's all from our group, and that's all. Thank you.